Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I want to do some experimentation with this thing. It's the RGB2HDMI, an open source project that lets you take a Raspberry Pi W along with this top hat board, which has a CPLD on it, and convert analog signals, or retro computer video signals basically, into HDMI. I've showed this on a mail call. This was sent in by Aaron, who runs the channel Retro Hack. So check out the description, the video in the description below. I will link to that video so you can check it out. I kind of show off this thing a little bit there. I've also done some work on this with the Laser 128. But what I really want to show is if I can get this thing working with a Macintosh Classic. Also, you may notice this Sony Trinitron TV on my desk here. I'm having a series of videos on the second channel where I take a look at some cool TVs like this. So check that out. I'll put a link in the description for that so you can get to my second channel if you haven't already done so. Anyhow, without further ado, let's get right to it. So one thing about these old Macs is they don't have any video output. Well, not without special cards, which aren't very common these days, and even with those special cards, the video output's not standard. But on a machine like this, which is actually, well, the case is a Macintosh Classic too, but there's really a Macintosh Classic in here because this is an amalgamation of various machines. But Classic 1 and Classic 2 machines don't have an expansion slot, so, oh, actually there's no motherboard in here, so I'm gonna have to find one to stick in here. But Classic 1 and 2 machines, they don't even have a video expansion built in. So there's no way just to connect an external monitor up to these. Now, if you've ever seen any of Apple's old keynotes from back in the day when the Macintosh was a new computer, they had seemingly a way to get Macintosh video from one of these onto large projection screens. Not really sure what they were doing to make that happen, but I'm thinking that I can use something like the RGB to HDMI here to very easily get video output from this and display it on my monitor there. Now, why would I want to do this? You know, who knows? Is there really a reason? No, not really. I suppose if you had a bad screen and you wanted to replace this with a LCD, you could then use this internal to the computer and put an LCD screen in here, replace the CRT, and that would work. Or if you're like me, you want to maybe display classic Mac video on a larger screen, you could do that. You could put it on your 65-inch OLED if you wanted to. Or also another possibility is maybe video capture is something you want to do. I actually have an Elgato USB 3 capture device there, which I'm intending to use for videos to better show the video from computers instead of having to like film the CRT, which looks pretty terrible. So let's see if I can get this working with the Mac. First step, open it up. With the cover off the machine, I've inserted a Mac Classic motherboard. I like the Classic motherboard for this type of testing, specifically in that it can boot off the ROM disk, which is just handy because there's no hard drive or floppy drive in this machine, as you can see. I'm just gonna power this thing on, make sure it still works, and I'm holding down Option Command XO, which I think should boot off the ROM disk. And I've installed a battery on the board, so once this computer boots up, I can go into Startup Devices and set it to permanently boot off the ROM disk, so it will do it without having to hold down this very awkward key combination. There it is, it's actually booting. Like I said, there's no hard drive or anything in here, just a big empty space there. Startup Devices, and we pick boot disk for the ROM disk. And while I'm at it, I'm going to turn the brightness down. The CRT is very, very bright, very strong. So now, if we shut down the computer, oops, boy, this mouse does not work very well. At least not without a mouse pad. Turn off the machine. Wait a moment. Turn this back on. It should go straight to Finder without having to hold down, like I said, without holding the awkward key combination. That's a good top tip. There it is, booting right up. So let's talk a little bit about the way the RGB to HDMI works. So as I mentioned before, it's a Raspberry Pi Zero. I guess you could use any Pi, but This is the one it's running. And it does have like a bare metal OS. It doesn't just run Linux like a normal Pi, so this boots very quickly. This on the top here is the hat. It's called a hat because it sits on top of the Raspberry Pi board. And it basically is what's digitizing the video signal, which is connected in through this 9-pin connector here, but it could be anything really. It digitizes it and it sends it through the GPIO pins to the Pi. There are buttons here for controlling the menu and stuff. There's a reset button, a couple LEDs. But the CPLD is doing the heavy lifting of like the clock synchronization. And when I say clock synchronization, the horizontal and vertical sync pulses that are coming through this cable here, it all needs to be synchronized perfectly so that the digitized signal is pixel perfect. And I guess the CPLD really makes that happen. So by default, the CPLD board here, when you just have a cable connected like this, is set up to capture digital signals. So it's RGB as in red, green, blue, but if you think about digital RGB, you're thinking about like CGA or EGA. And really what that means is all the signals that come in through this connector here are 5 volts. The various video signals for red, green, and blue, there's an intensity bit, and the horizontal and vertical sync, all 5-volt signals. Well, on the Mac, the motherboard here is driving the CRT, which is hooked up to this analog board here, through this cable. And this cable here, all the signals that this Mac generates are also 5 volts. So the video signal, this is a monochrome machine, so it's simply 1-bit video, along with the horizontal and vertical sync, it's all 5 volts. So theoretically, all we need to do is connect the output of the motherboard to this device on the horizontal, the vertical sync pin, so that's 2, the video signal pin, so that's 1 more pin, and ground. So we really just need 4 wires. Now this is ready to accept RGB, but I'm just going to connect it up, I think, to the green input on here, which is sort of a common use for a monochrome signal. And then you can configure the palette to just say that I'm looking at a black and white source, and then we have to adjust all the timing and stuff because the timing that this uses is not standard like CGA or many other computers. But this thing is so flexible, this RGB to HDMI, this project is so flexible, this should work. So the first step to see if I can get this working is I need to pull this analog board out so I can get those signals from that board into the RGB to HDMI. If you'd like to see more about repairing these types of Macs or taking them apart, check out my Macintosh Repair-a-thon series. I went through several of these Macs, took them apart, swapped parts around to make working machines. In fact, this power supply board is not the one that originally came in this particular chassis. This was one from that original Repair-a-thon series, and I have cap issues written on the back because yes, this actually had some problems on it. Very leaky capacitors. Oh, I think that's it. 2 screws and this comes right out. It had very leaky capacitors, and changing them out didn't initially fix this thing. I had to actually soak this board in alcohol because a bunch of the electrolyte had gotten into the pinholes for the voltage regulation on this board, was causing all sorts of issues. But once I soaked it in alcohol and then I used compressed air to blow all the alcohol and capacitor juice out, it worked perfectly ever since. I have to add the disclaimer that please don't work inside monitors and CRTs unless you know what you're doing. There are high voltages in here, especially if you have the mains power connected, that could be very dangerous to you. So let's take a look at the wires that come from the connector that comes from the motherboard. That goes right on the analog board right here. Now you notice I already have these wires soldered on here. These are actually the signals I need for this experiment. These are on here not for this experiment, but for a different one, where I was using a Raspberry Pi with an emulator to actually drive this board directly and the CRT in the Mac without the original motherboard. The idea there is that you could run RetroStation and emulate a Mac or any other computer, but display the video from that on this CRT. Unfortunately, that experiment didn't really go so well. I put some posts on Twitter. This was a while ago I did this experimentation. I think maybe it was last year or even the year before. The problem is that the DPI video output on the Raspberry Pi, that's video over the GPIO pins, has a lot of limitations for the clock that you can use and frequencies and stuff like that. And this analog board requires very specific timing. It is not wide range like a VGA monitor where it supports all sorts of frequencies. It supports 1 frequency, 1 refresh rate, all that stuff has to be exact. And unfortunately, the Pi just can't do it properly without issues. I won't get into all those details, but that's why these are here, is because I actually had it kind of working, but it just didn't work properly, not quite good enough. But because these wires are just still here from that project, I just need to connect little extension cables to that, run it outside the machine, and then we can give that a try. The only thing I don't know is I'm not sure which wire is which. So we're gonna have to go to the schematics, take a look to find out which of these cables actually is which signal, so I can write that down and hook it up properly. All right, so I have the Bowmark schematics up for the Mac Classic. And right here, I think we're on page 2. It shows the various things that we need. So there's a brightness control. We're not going to be touching that. Here we have 5 volt peak to peak is the composite video signal. Now it says composite, but the reality is this is not actually composite. This is just the video signal. But 5 volts peak to peak means it's just regular digital RGB, same as CGA, so fully compatible with the CPLD that's on this board. Next up, we have horizontal sync, which we definitely need, and then we have a vertical sync, which we also need. Now, the polarity of these may be a problem, but I don't think so, because I think this project is so flexible that it can handle the various polarities. We'll figure that out once we get this hooked up. So of these 3 signals, plus we'll get a ground lead, I need to know what colors these are. And the colors are actually written right here. So W for white, V for violet, and GY I think is either green, yellow, or nope, that's gray. So GY over here is green, yellow, which is like a green wire with a yellow stripe. This is for the sound. We're not gonna be hooking that up. So I think I need to look for a gray cable. So of these leads that I've soldered on here, I have the brown one connected to the black wire. That's gonna be ground. I have the red wire going to the white cable. According to the schematics, white is the video signal. Then the orange cable goes to the violet cable. The violet is horizontal sync, and the yellow wire, that one goes to the gray wire, which is the vertical sync. So I'm just gonna write this stuff down on a Google Sheet to keep track of it. So we have white, that goes to red, the black wire goes to the brown lead, the gray wire, as we just determined, that goes to the yellow lead, and the violet wire goes to the orange. And these are the little short DuPont ones that I have on there. Now I'm gonna hook this extension lead, come on, focus, there we go, up, and I just need to write down these colors. I didn't happen to have one handy. That was the same colors. So I'm going to make the ground the black lead, then I'm gonna make the white lead on the extension, the video signal. Then I'm gonna make, oh, it's how weird, it's the same exact colors. I'll make the gray lead the V sync, and I make the violet lead the H sync. That was completely by accident that I picked the same exact colors as what was coming off the motherboard going into the analog board. That's funny. There's one more thing I'm gonna need to put on the spreadsheet, and that is the VGA pinout. And that's because on this device here, this 9-pin connector, I have it set up for the same pinout as VGA. So to know where to hook things, I'm gonna just write that down as well. So pin 1 is ground, we absolutely need that. So I'm gonna write CGA here. So the ground lead is gonna go to pin 1, and then where's VSync? VSync is on pin 9. We have H-Sync on pin 8, and of course the video signal, I am just gonna attach this to pin 4. So with this information in the spreadsheet, I'm now ready to take this 9-pin connector and this lead, I'm gonna cut these ends off, and I will solder this straight onto here, and then we can test this out. And that was it. Pretty quick and easy to solder this together. I'm not gonna put a hood on this or make this perfect. If this works, I can do a better job at hooking this up in a permanent way, but this is for testing. And now it's just a matter of connecting these DuPont connectors together, and these are knockoffs from China, so they're not always the best quality. So the white wire, that goes to the red wire. That's why I made my little spreadsheet to help me keep track. The violet wire goes to the orange wire, and the gray wire goes to the yellow one. Now I'm just gonna reassemble this Mac, make sure everything still works. So the Mac is still working perfectly. I do not have this hooked up to it yet. So I'm gonna power this up first. I'm gonna use a power bank to do it. We should get the video output on my HDMI monitor here. Great, so everything is working. There's the menu. I am going to connect this up, and we're gonna see what happens. Hopefully I don't have smoke. All right, so right off the bat, we're actually seeing a bit of an image. Ha-ha! So we can see back here that it's definitely picking up the Macintosh. but it's definitely not running in the right resolutions and stuff like that. So I'm just gonna go fiddle around in here and just try to get this looking good. There's a lot of settings in here and I'm not gonna go through them all. There are lots of other videos on this, but I'm gonna see what I can do to make this look good. And after much tweaking, I'm ready. Check this out. I'm gonna turn on the Mac. Do you see that crosshatch pattern? That's what's there on a Mac Classic when you turn it on. You just never see it. And there it is. Pixel perfect Macintosh video displaying on HDMI. If I go through the menus there, you see it's all very much in sync. Open this up. And yeah, it's amazing. I mean, I don't know what else to say. I love CRTs, don't get me wrong. I have a lot of CRT videos on the channel. Everyone knows that. But on the other hand, stuff like this is just so darn cool. And I think for this video, I'm gonna try to break out the video capture the device, the old Elgato. Let's see how this looks captured. All right, this should hopefully work. The Macintosh video outputs through my cable here into the RGB to HDMI. The HDMI cable goes from this into the Elgato HD60S capture device. And then the HDMI from this plugs into the monitor. The USB 3 cable goes to my laptop, which is off camera, and it is recording right now. And here we go. I'm going to turn on the Mac. Let's see what we get. Okay, so the computer, the laptop that is over there, I see the video being captured. So let's hope we have a pixel perfect Macintosh video capture. Now, one thing I am noticing is there seems to be one line of pixels that's somehow duplicated or something. Yeah, I can just make it out on the mouse pointer there. You see that? Right here. That's not the Mac. That's definitely somehow in, I guess that's in the configuration on the Raspberry Pi. So I'm gonna bring up the menu on here so I can show you all the settings. I am going to talk to the maintainer of this project, Ian, and I'm going to give him the config file so he can load this in, and this will be part of the distribution. But in case that doesn't happen by the time you see this, you can put these settings in yourself. So here we go. On geometry menu, I'm going to use the mouse pointer on the Mac. You'll see all the various settings here. One really important setting is this one. This is 15.6672 megahertz for the clock frequency, which is what the Mac runs at. Lines per frame is 370. The line length. That's weird that it says 1024 because I had that set to exactly what the line length was, which I don't remember off the top of my head. It's not 512 because it has the front and back porch on there. Something like 570 or 560 or something like that. I don't know why it defaulted back to 1024. I'm gonna fix that. Maybe I forgot to save the configuration change I made. Other important settings, it's a positive horizontal sync pulse, but it's a negative vertical pulse. And what's freaking awesome is that this project allows you to configure exactly the polarity of those pulses. It generally worked actually with it set to plus H and plus V, but because it wasn't starting the sync on the exactly the right spot, it was starting it at the end of the sync pulse as opposed to the beginning, it was cutting off the bottom several lines of the picture. But with it set correctly, it now works perfectly. In the sampling menu, we have 1 bits per pixel, which of course is important because we are running at 1 bits per pixel. There is no color. I assume you can have the video signal going into any of the RGB pins, R, G, or B, and you'll get the black and white, but of course I have it in the green one. If I change that to like 4 or 8 bits per pixel, we will get a green image on this machine. There's the frame rate, 60 hertz, but it's actually 60.15, which is the actual frequency that the Mac runs at. Pixel aspect ratio is 1:1. Now the aspect ratio isn't quite right because this Mac actually is not a 1:1 because of the exact resolution, which is 512 by 342. I think 512 by 384 would be a 1:1, but the original Mac does not run at a 1:1. I am going to try to adjust the line length to be the correct line length again. I must have changed it and then forgot to save my settings. So the correct line length on the Macintosh Classic, at least, and I'm sure it's the same on all the Macs, is actually 704. So let's set that. 704, that's it. Ow, yeah, I was pushing too hard on the button there. Looking back at the source summary, clock error is now 27 parts per million, so a lot better than it was. That did not correct this extra weird line double thing happening right here in the middle though. So not exactly sure what that one's all about. I'm going to change the scaling from auto to something else. I'm going to change it to interpolate soft. All right, so the aspect ratio now is much more correct. Well, it seems to be more correct. Also, that extra doubled pixel is gone. So really that setting, whether you're going to run in the integer scaling mode, which is what auto was using, versus the soft mode, is totally up to you. I kind of like the way this looks, to be honest, for two reasons. The aspect ratio is now correct, but the other reason is that the size, it fills up the screen properly as well. There's no border on the top and the bottom anymore. It literally goes right to the very edges. It's just so cool. Let's turn this thing off and plug in a SCSI device so I can boot up to something other than the ROM disk. Here's the SCSI to SD, and I have a 25-pin connector on here, so I can just plug this straight into the Mac. And the cool thing about when you do it this way is on most Macintoshes, you don't have to provide power to the SCSI to SD, and that's because the termination power that comes out of the Mac supplies 5 volts over the SCSI cable is actually enough to power this thing on. So I'll turn this on. You notice the light flash there, and that's because this thing is actually powered up. SD card thingamajiggy here. All right, so we got some games going on here. Let's see, where's my favorite one? Crystal Quest. And you'll be able to see like a perfect capture of this game running on real hardware though. How cool is that? Of course, this machine is slow, very slow. Here we go. Oh, there's all some of my scores. Yes, I actually got to level 38. First score there. I mean, I did that a while ago. Now, the sound, you're gonna have to hear through my microphone. And I don't have a mouse pad, so this is not ideal. If you haven't played this game before, I highly recommend it. It's very fun. When I was a kid, I played the heck out of this game. You do have to push the space bar to activate your smart bombs, which is right there. It is a color game as well. Boy, I haven't hit anyone here. I don't generally try to shoot things. I only shoot them to get out of my way. So that's Crystal Quest on an HDMI capture off real hardware. Can anyone tell me if that's ever happened before? So yeah, this thing is working incredibly well. The RGB to HDMI project is freaking cool. I can't say enough about how cool it is, and I have ideas about other places I can use it to give HDMI output on those as well. Like if it can work on this because of the flexibility of the RGB to HDMI, it can work on tons of other old machines. So I want to thank Aaron again from Retro Hack Shack for giving me this RGB to HDMI. I definitely need to go find some more of these to make. I think Noel on Noel's Retro Lab, he ended up just getting some PCBs made so he could make them himself. it's an open source project, so it is completely something you can build yourself if you can't find someone who sell you one that's already made. It does have some surface mount components, so be ready for a little SMD soldering. So anyhow, I hope you found this video interesting. I know I had a great time doing it. If you did, I'd appreciate a thumbs up. Please subscribe to the channel. Don't forget to check out my second channel. And I want to give a huge thanks to all my patrons who have just been supporting me, and it's absolutely amazing. You will see their names scrolling up on this side. Hopefully I'm pointing to the right side, because I always point to the wrong side. And put your comments in the comment section below, and you know, all the other YouTube stuff. That's all the usual things, and that's going to be it. Stay healthy, stay safe, and I'll see you next time. Bye-bye. Look at this, it's so crazy.